Hello friends, myself Gandhar Kumar. I am taking power electronics for third year electrical engineering students. In the previous lecture, we are discussing various parameters which are associated with the power electronics and discussing about the control rectifiers or the single phase, three phase, their characteristics, their waveform, and their circuit diagram, discuss the circuit diagram and their waveform, how we have to make it. Now we are just discussing all the effect of source impedance on the performance of single phase and three phase control rectifier. As we know that the source inductance are the important parameter because while we have to just look over the devices which will be available to us in giving the supply, if they are all making by the coil and coil consists the resistance and inductance, they are manufacturing the supply is generated with the help of the generator. Generator consists in the source inductance. Transformer which we are using to deliver the supply towards the consumer. It also consists the winding. So there is a source inductance. There will be a transmission line which also includes the resistors and the inductance. The wire which we are using, every wire having some resistance and the inductance. So the source inductance will be the important parameter while we are just to go over the power electronics controller, especially in case of the rectifier designing. The analysis of most converter is usually simplified under ideal conditions. No source impedance, no source impedance are to be taken in care. However, this assumption is not just since source impedance is normally inductive within negligible resistive element. Source inductance has a significant impact on the converter performance because its presence alters the output voltage of the converter. As a result, the output voltage reduces as the load current reduces. In addition, the input current and output voltage waveform change significantly. The source inductance effect on a converter is analyzed in the following two ways. First, effect on single phase type device, single phase sourcing, and the circuit diagram it will be indicated over here that after the source, whatever we are taking, we are assuming that there will be some inductance already placed in the circuit. If we are looking over the single phase supply, there is a thyristor, there is a four thyristors are there and the inductance will be acting as a source inductance and we are deliver the supply towards this one through the SCR to load. So there is a current, we are measuring the current over at that moment that what will be the impact of the source inductance under this one. So in place of a load, we are just placing a emitter or a current source over this side so that we can imagine the differences which will be arising over the assuming that the converter operates in conduction mode and the ripple from the load current is negligible in nature. The open circuit voltage becomes equal to the average DC output at a firing angle of alpha. The diagram below shows a fully controlled converter with source in single phase. The thyristor T3 and T4 are assumed to be in conduction mode when T equal to 0. On the other hand, T1 and T2 require when omega T equal to alpha. Where Vi is the input voltage, Ii is the input current, Vo equal to output voltage, Io0 equal to output voltage, output current. When there is no source inductance, commutation will occur at T3 and T4. Immediately, thyristor T1 and T2 are switched on. This will lead the input polarity to shift simultaneously. In presence of source inductance, the change of polarity and commutation does not occur instantaneously. Thus, T3 and T4 do not commute as soon as T1 and T2 are switched on. At some interval, all the four thyristors will be conducting in nature. This conducting interval is also called as the overlap interval indicated by the nu. The overlap during commutation reduces the DC output voltage and the angle of extinction gamma resulting in paired commutation when alpha is close to 180 degrees. So this will be the waveform which we are finding over this side that there is a conduction period of the device which will indicate by the BO at that moment And similarly, we are getting the same kind of signal over here because it will be rising while the alpha angle will be taken by the thrusters and it will be come on with an angle of alpha. Then there is a conduction angle is there. So there is a time period of the T1, T2, T3 and T4 which will be indicated over this side and respectively we are getting the output current and the input current and the output current of the devices. This will be the effect of on three-phase supply. Thus, just like the single-phase converter, there are no instantaneous commutations due to the presence of the source inductance. Taking the source inductance into consideration, the effects qualitatively on the converter performance is the same as in a single-phase converter. So over here we have the three sources. We are assuming that the individual phases which are connected in series, they are connected in parallel and form the three-phase supply. And individual phase having a inductance L, it will be connected over there and it will work as a source inductance. And they are connected with the T1, T3, T5, T2, T4, and T6 with a load side. It is important to determine the performance parameter for different converters whose topologies can be explained in single phase or multi-phase type. Assumptions which are taken, the devices used are ideal, that is, they do not have any losses. The devices have resistive loads, DC voltage on load, RMS voltage on load, form factor are there, ripple factor is there, rectification factor is there, transformer utilization factor is there. So these are the different components which we are measuring while we are just working over the devices. So these are the parameters which we have to calculate while we have to perform any kind of operation either for the single phase or for the three phase calculating the performance parameter. Thank you.